Hey, what's going on, folks? It's Mike here, and welcome back to my SDL3 programming series. In today's episode, we're going to look at how to flip our sprites to save a little bit of memory here in our actual sprite sheets. So let's go ahead and take a look here. And just to give a little bit of a recap in the last episode, since we covered quite a lot here, let's go ahead and rerun and recompile our program. We got our sprite running nicely here. Now, of course, it's running probably too fast here, and we might want to limit that, or maybe you've added in some little ways to limit how fast your sprite is moving. But basically what we did here is we built this little animation structure. Now we have a frame which consists of one part of our sprite. So let's go ahead and open up our sprite sheet just so we have that available here. The walk bitmap here. So here's our full sprite sheet here. And a frame, as shown on line number 8 here, is just a selection from this sprite sheet here. An animation is a selection, or excuse me, a collection of those frames that we have collected. Say that 5 times fast, hopefully. But anyways, an animation stores all those frames. So, and this is useful if you have some, again, JSON file to collect all of these frames together and then be able to play them. They might be on multiple lines here. You could specify these one at a time here and add the multiple frames. So again, it just gives us a little bit of a structure. And as I mentioned last time, you could add some properties for how fast to go through each of the frames here and so on. But anyways, that was the basic premise of the previous episode. And then in our sprite structure here, we have the animation, we have the texture, of course, the destination or rendering to, and then the source, which was just sort of a convenience for us to otherwise just assign to the source an animation. Again, you don't necessarily need to have this as a separate collection of, bytes here. It might save you something. You could save some memory here by just going directly from the animation, but maybe you want to freeze frame or select a specific, I don't know, location of some other texture here to draw to. So it's kind of nice to have it separated out just to make things easy. Okay, so anyways, that was it. And then our sprite structure otherwise remained the same. We have the color keying code here for our surface otherwise, and then we can move and update our sprite here. Now, the sort of interesting thing about our sprite here is it just moves to the right here. We're just incrementing the pixels one at a time here. So what might be neat here is if we kind of bound this here. Okay, so let's go ahead and work on that here. And what I'm going to go ahead and do here is let's move this just a little bit faster here, since it looks like our guy's essentially running since we're playing the animation really fast here. And what I want to do here is just store a little bit of state here. And I want to say if our destination is greater than 320, then we want to basically move our sprite to the other direction. Okay, so this is what we're going to kind of do here. Now I'm just going to, for the sake of this video, just create a static variable here and just assign it to whatever the x direction is here. So for greater than 322, let's just, or excuse me, 320, let's say our x direction equals 0. If our sprite otherwise moves less than 0, let's just go ahead and change the direction here. And then we'll just go ahead and say something like m destination, or excuse me, x direction equals 1. Then we'll do this. Otherwise, we will decrement the position here. Okay. So let's just do something like this. And let's see what our program looks like here. Okay. So we got our guy running here. Now, a few things here. We got to see, is our guy going to run totally off the screen? Well, again, remember the top left corner of our sprite is where the location is here. Okay, so when you're bounding your window, you want to keep that in mind here. I think it's going to work properly on the left side. But again, this looks a little bit weird if our guy is basically backwards running, so sort of doing a moonwalk. So let's do a little correction here. Again, these are constants here. So we probably, right, we have our sprite dimensions here. So let's do it a little bit properly here. And the destination width here. Okay, so a small little correction there. All right, guy's going to run almost to the corner, and he's going to moonwalk, so to speak, backwards. And that looks a little bit better here. Now, what I really want him to do is to flip and turn the other direction here. Okay, so we have a few different options of what we could do here. So again, if I open up our sprite sheet for our walk animation here, I do have this other set of frames that I could load up and play here. But that's going to take twice the amount of memory here. So what if I could just flip or basically reverse the pixels? And we have a function to do that in SDL here. Okay, so let's go to the SDL documentation here. Of course, follow along in the lessons here. There's my advertisement for that. Let's just go to the API category. I'm going to go into the rendering. And let's just go ahead to SDL render texture, which we've been using here. Let me make sure I spell it right. Texture, something like that. If I zoom in a little bit here, you'll see, hey, I have a few other functions here. I have tiled, rotated affine, grid tiled, a bunch of these things here. This is the one that we're familiar with and using, right, where we render our texture and we have our source and destination here. But this one here, rotated, is kind of interesting. So I can actually rotate the texture by providing, again, the render and the texture. That's the same here. Our source is the same, our destination, but we have these additional parameters here. So we have the angle. We can figure out where we're centered about. So if you didn't like that top left corner is where we're centered about, and this becomes important with rotation, you can actually change that. But we're going to look at this flip mode here. Okay, so let's see what the flip mode is here. Let's go ahead and click on that here. There's a few different ways that we can flip things, right? We can flip horizontally, so across the y-axis, or vertically across the x-axis. Okay, so we're effectively mirroring our sprite. Okay, so let's go ahead and play with this function here. And what we're going to do is, let's take a look here at where we're doing our render. Right, we're doing SDL render texture, but instead, let's give ourselves a little bit more power, and we'll do SDL render texture. What was it? Rotated. Let's go ahead and just copy this texture. Yeah, rotated. And let's copy all the parameters. All right, so go ahead and paste this in. And let's kind of fill in the blank here. Okay, so I'm not going to do anything with the return type. The render is just R. The texture is, well, M texture. Our source is going to be the same here. The address of M source, which is a member, basically just taking in our animations. The destination, again, remains the same. The angle, let's just for now not worry about that. So just 0.0, 0.0, since this is a double value. The center here looks like we do have to set, and we do have to set the flip mode here. Okay. Now the flip mode, it looks like we had a few of those defined here in this enum here. So let's just go ahead and try this out here. Let's go ahead and fill that parameter in here. Let's pop that in here. And then the center point here. Okay, so let's go ahead and see from our documentation what the center point is here. And this should just be a point structure here. And let's just go ahead and initialize one of these guys here. Let's go ahead and do here. I'll just call it center, and .x equals 0, .y equals 0. Should be a comma, and 0.0. Because these are doubles, and C++ doesn't really care, but we can do that here. Okay, and let's just pass that in as address center here. I might need to make that const, but yeah, that's working here. And now look, our guy is going backwards here. Okay, so let's get this settled once and for all here. Now it looks like we'll need to store some state here to figure out if we're going, if we should actually flip our character or not. So how can we do this here? Well, basically for those enums, we had flip horizontal or flip none here, which again was our sort of default state here. So I could store this as the state here. Let's go ahead and do that here. And let's do that in our sprite class. So again, we'll have some different properties here. So SDL flip, let's see here, flip, let's see here, flip. What was this? Flip mode. Okay, there we go. Let's see for, yep, flip mode. Oops. Flip mode. Let's default that to SDL flip none. Okay. And then based off of the direction, so if we are incrementing, let's see, this way, flip mode equals SDL flip none, Otherwise, here we will do horizontal. Okay, and let's go ahead and then just pass in here and flip mode. Okay, so let's see if this does our little trick here. All right, running and running to the left, or to the right rather, increment the X position and flipped. Okay, so pretty cool. So again, if you've played Mario or these types of things here, where you have the Goombas, for instance, where we're just walking back left and right, like this patrol officer, or however you want to call them, this hero or enemy, we haven't decided yet. We've just effectively, we can get rid of one entire row of our sprite sheet, right, by just flipping the texture. Now, of course, if there is something different when they're looking left versus right, like there's a, I don't know, feature on the character's art or something, you know, thinking about some like character like Two-Face in Batman, for instance, that has different artistic, design, you might not want to use this trick, but in general for a game, we could probably get away with this to save some memory. You know, maybe for our main character or something, we might not want to do this, but again, this is just something nice to know about. And if at the least we've seen some different ways to render, and of course we have different ways to rotate as well with this function here. Now, we haven't really introduced any matrix math, so to speak here, which is where the angles are useful, but just to give a little bit of a preview of that, if you do want to play around with that, let's just create a variable here. I'm just going to call it increment here. Increment plus equals 0.1f. So that's going to be the angle here, right? Let's see what happens when we rotate the angle here in the center point, just to play around with that here. Let's see here. Oh, that might not have been enough here of an angle. Let's do something like this. There we go. All right. Well, look at that here. Now our guy is rotating around and about here, so you can start creating some interesting things here. And again, you can notice that the angle that it's moving, or rather it's rotating, it's still in a straight line here, but it's giving a interesting illusion here. But it's kind of, we'll really have to introduce some of the matrix math here, because we can see, hey, we're going out of bounds here. So maybe that'd be something that we cover, or maybe I'll cover that in some advanced lessons or something. But you can start having a little bit of fun with that if you want to start playing around with rotation. So anyways, I'm going to get rid of that here, but I am going to leave in the flip mode because I think that is important how that works, and it works kind of nicely. Actually, while we had the rotation going, let's see if we fix our center point, does it look better, right? If we do it about the, middle here. Oops. There we go. Let's go ahead and rebuild here. Let's see if that kind of made more sense here. We have our increment. Yeah, it's looking a little bit better here. Let's rotate it faster. Okay, while we have this set up here, just so you can have a little bit of fun here. Let's go really fast, 1.0. Okay, there we go. Now they're rotating like crazy. But eventually going to run out of the screen here. So again, you can use that sort of rotation if you want here. We'll prefer probably to do some matrix rotations to get things completely right here. But anyways, that's a little bit of fun here for you. But anyways, I'll get rid of this rotation because we don't need it yet. But we do need to pass in some arguments here. So just pass in 0 if you don't want that. Alrighty, anyways, folks, I think that's enough for this lesson. Thank you, as always, for your time and attention. Hopefully you had fun with this. And we get a nice little improvement here with our sprites while learning with, some of the other SDL3 functions here. All right, folks, with that said, I'll go ahead and see you in the next lesson. Thanks again for your time and attention.